Welcome to the HiperLAM project, a European-funded project aimed at improving the speed and cost of additive manufacturing. The printed electronics market requires technologies that are versatile and can be adapted to address rapidly evolving demands. HiperLAM integrates additive manufacturing solutions designed to replace multiple process steps currently used in production. The project used laser-induced forward transfer, known as LIFT, a technique for printing electronic circuits in high speed and high resolution. In HiperLAM, two applications were chosen for demonstrating the technology: Pragmatic's RFID antenna and FlexEnable's fingerprint biosensor. For RFID antenna, the aim was to increase throughput 10-folds and reduce production cost 20 times. For biosensors, the aim was to achieve 5 times faster lead production time and reduce production costs by half. The supply chain of each demonstrator consisted of multiple steps: high viscosity nanosilver and nanocopper inks to enable fast donor coating, high resolution lift printing process technology to print conductive lines to 20 micrometers, high resolution selective laser sintering, high resolution surface patterning process technology, process control and quality assurance to advance the manufacturing readiness, and modeling of additive processes to support optimization strategies. The research started with nanoparticle inks creation in PV NanoCell's lab, where silver and copper were both explored for the project. Inks were gradually optimized for the applications until good results were achieved. The inks were distributed to the 3 printing partners, which formed the next step in the supply chain. At each of the printing sites, nanoparticle inks were uniformly applied onto carriers to form donors. Sophisticated lift tools were built by Orbotech, TNO and NTUA in order to test and optimize the printing process. Full-scale RFID antennas and fingerprint sensors gate layers were reliably printed. The printed patterns were then all sent to Oxford lasers for sintering and patterning. Laser sintering is a process required to make the printed pattern conductive. In addition, laser ablation was used to shape the sintered pattern, and sophisticated tools were built to demonstrate these processes. Finally, all the sintered and shaped patterns were sent to the relevant end users, Pragmatic and FlexEnable, where the applications went through final production processes and functionality testing. In HiperLAM, LIFT, followed by laser sintering, proved to be a promising solution for future electronics additive manufacturing to produce circuit boards in precise, clean, and economic ways. To find out more about the project and to get in touch with our partners, please visit www.hyperlam.eu.